Welcome to the Falling Walls Plenary Table, Backing Wild Ideas. HEIs, Research and Innovation in Europe.
Good timing.
Welcome, everyone. I am thrilled to be moderating this discussion as part of the Falling Walls Circle Plenary Table Sessions. My name is Stacy Bloom. I'm New York University's Chief Research Officer and Vice Chancellor for Global Research and Innovation. The topic that we're delving into today is one that is absolutely central to Europe's future scientific capacity. And our topic is called Backing Wild Ideas, Higher Education Institutions, Research and Innovation in Europe. Our goal over the next 50 minutes is to insightfully explore how higher education institutions can best champion risky, transformational, and truly wild research. We will look at the challenges in funding, institutional structures, and cultural shifts necessary to turn these bold ideas into breakthroughs. On that note, I'm very happy to introduce our esteemed panelists. Heinrich Arnold is an innovation manager at the board level and a member of the governing board of the European Institute of Innovation and Technology. He is an honorary professor at TU Berlin and previously headed Deutsche Telekom's R&D division, overseeing activities across Silicon Valley, Berlin, and Israel. Rafael Laguna de la Vera is the founding director of the Federal Agency for Disruptive Innovation, SPRIND, in Germany, which is tasked with identifying and funding radical, market-transforming technologies. A veteran tech entrepreneur and advocate for open source, he co-founded and served as the CEO of the software company Open Exchange. Professor Orla Feely is the 10th president of University College Dublin and the first woman to hold this position since assuming office in May of 2023. She is a distinguished professor of electronic engineering and is the first Irish woman elected as a fellow of the Institute of Electrical and Electronics Engineers. She is also the president of CESAR, a network of more than 50 European universities of science and technology. Professor Mark Thompson is a British particle physicist who is the Director General Designate of CERN, set to begin his 5-year term in January 2026. We are putting him to work early. He is currently a professor at the University of Cambridge and previously served as the Executive Chair of the UK's Science and Technologies Facilities Council. Milena Stojkeva is a global technology and innovation evangelist, currently serving as the CEO and co-founder of the EDGE R&BD. She is a recognized leader in entrepreneurship and education who previously served as Bulgaria's Minister of Innovation and Growth, shaping policy at the intersection of technology and youth empowerment. She is also the co-founder and board member of EU Female Founders Forum and the VC lead at JA Europe, building an early-stage impact and deep tech fund for discovery. Welcome, everybody, to the table. And we are so lucky to have such an extraordinary mix of expertise and talent. Let's get to work. My first question for the speakers, for each of you, and you can take this question in any order you want, is really around funding mechanisms and uncertainty. So Europe's research funding landscape has traditionally been geared towards very clearly defined deliverables and incremental progress. In your minds, what specific regulatory or financial changes must be implemented in order to create mechanisms that are dedicated solely to high-risk, high-reward research? And I would ask you to spend no more than 1 to 2 minutes on this question.
You're looking at me.
I'm going to start with you.
Actually, we tried to implement such tools at SPRIND, and maybe the sort of philosophical level of this is that we're turning sort of micromanagement and distrust-driven approaches into something where we trust the people that do these things a lot in advance, but we look at results, what's coming out. So we implemented a challenge format where we are asking a big question of our time that we want solved, like broadband antivirals or long-term energy storage or deepfake detection, you name it. We just closed the call for the Tech Metal Challenge, which is looking for recycling electronics into raw materials and compounds. We get 50, 100 applications. We select, a jury selects 10 to 15 teams because we all believe them and they're pitching and we trust them and we'll all let them go and work and support them as much as we can. And eventually they come back and show what they've done. and then we look at the results. And then a couple of teams, like 60 to 80%, can continue, more money, next round, rinse and repeat. So we're just letting these people alone. There is no anything thing forms to fill or future to predict, which is kind of wild when you're talking science, that you have to say where you're going to. So there are ways, and we're a government agency, so governments can do that, and just trust in the people that are driven by the things that they want to do, because all the people that we meet are simply that way, instead of micromanaging from a ministry.
First of all, maybe to say something that we do very well. The European Research Council has been transformative on the European landscape, and it is for exactly what you say, Stacey, high risk, high reward research. And that's great. And all the metrics show that Europe does as well as anywhere else in the world in terms of the fundamental research. But the metrics also show that we do not do nearly as well as the huge innovating systems, particularly the United States and now China, in terms of the innovation outputs that come from research. So as you said, I'm an electronic engineer. We think in engineering about impedance matching. You have one system feeding another system, and you have to manage that interface very carefully in order to get optimum transmission from one system to the other. So I think that we really need to look and manage very actively that interface from the research, which we do very, very well, into the first stage of innovation outputs. So we need to link our researchers up with entrepreneurial supports. We need to introduce them to prospective CEOs. Let me give you one example of where we get in our own way in Europe. If we say in our university, if we have state or European funded research, the researcher cannot engage in any commercial piloting or testing of that work because that would be considered state aid.
Okay.
This is nonsense. We need to be able to, and this could be managed with guardrails around it. We need a sandbox. I don't know if that word translates across languages, a space where people can play at that interface. Yes, with guardrails to make sure it is done ethically and appropriately, but to get our researchers interfacing with the commercial world with their ideas much, much earlier. Whereas at the moment, like I say, we prevent ourselves. We have walls around ourselves that prevent us from doing that. A similar one is in procurement. Many of our researchers have wonderful ideas that could be tested in hospital systems or public systems or university systems, but they can't do that because of public procurement rules. So we just need to, as I say, actively manage the interface out of the great research into innovation, because at the moment we are putting barriers in front of ourselves.
Those are terrific examples. May I move to Peter?
So, bad and good news. So, bad news first, more of the same helps. So, funding definitely helps. There is no cheap way into fundamental disruptive creation of wealth based on competence on insight. Good news is it's not 1990. So the question is, are Silicon Valley ecosystem effects possible outside of the Silicon Valley? Is answered, and the answer is yes. We are in a city that had its renaissance for a decade now, which is between 2006 and 2016. Berlin came back as a innovation center of international reputation, and kind of by coincidence, the magic formula has been found, which is bringing together deep competence from universities with established companies as the first organizations to create demand, create something that's investable, and then attracting investment. We kind of stumbled into this in 2006, 2007, and were actually surprised by the dynamics. Same effect happened elsewhere also. So the Beersheba Israel effect, creating the cyber security ecosystem happened in the same way. So we are pretty confident, and that's actually what the EIT is built on, the organization where I'm from, to do this not only 2 times in Europe, but 72 times to create these ecosystems where one thing adds to the other. It's not trivial. It needs a lot of money. And the secret is to actually use this mechanism of ecosystem to mobilize more money into the good opportunities to make them global, impactful effects.
Thank you.
Thank you. Your question makes describing the Higgs boson easy. This is not easy.
Your joke lands well in this room.
It's a good nerdy joke. Yeah, I mean, I think part of it is breaking down barriers, which I think is a very suitable way into this particular discussion. I mean, we do a number of initiatives across Europe in funding research and innovation. So there's specific research funding where we typically provide all of the wrong incentives, which is basically no risk, low risk, get a paper out of it, you're done. We should expect failure, and failure doesn't really mean failure, it means you don't necessarily succeed where you started. So the incentives there are wrong. In the UK, we have different ways of funding innovation. Sometimes that goes directly to business. Again, it tends to be quite incremental, low risk. There are other ideas, and actually we heard at the beginning, more disruptive mechanisms. So the UK has ARIA, which is basically give some smart people some money and let them go off and do something. I think the jury is out on how impactful that will be. The other one that I think is absolutely clear is then business and capital. And I think that's one of the gaps we have within Europe, the venture capital, patient venture capital. Certainly from my experience in my previous role in UK research and innovation, that's always a challenge. The other thing I think we all need to do is make the most of our assets. And in Europe, we have a huge number of assets. For example, medical data, tricky one, ethically. We're actually very good at having kind of internationally recognized repositories of medical data, but we don't necessarily make the most of those assets. The other element that I think is absolutely critical, I'm obviously very biased, large-scale infrastructure. At some point, if you're going to do something really disruptive, you need the top-end equipment. Actually, this is an area where I think Europe is pretty well placed, particularly through cross-European Union investments. And I think that's an area you need to focus on, and that's not just the big machines that I like, but it's big computational, the right computational, and computational computation that can support emerging, really rapidly growing businesses. So I think we have all of the elements, but we tend to place quite a lot of walls between the different elements.
Thank you.
Well, I will start with maybe making the statement that, to me, one of the big challenges is innovation starts where certainty ends. And this is something that we need to embrace and start looking at as an approach, as a culture in Europe, and applying it both in academia, with research, but also in the way the funding is looked at. So to me, Europe needs to start building much more fail-forward type of mechanisms that are fast, that are flexible, and that allowing that we learn from failure. And so failure needs to become it needs not to be looked as a stigma, but I would even call it support the culture where failure becomes data for us. And it is a way that we encourage experimentation and also curiosity much more than we are encouraging only the final outcomes of the work that is being funded. So currently, frameworks like Horizon Europe, Erasmus+, EIT, as was being said, are strong, but they're still, in a way, rewarding a bit more compliance rather than curiosity. So I think this process of moving from more risk rewarding type of mechanisms would be critical for Europe to respond to the very uncertain dynamic environment around us. And last thing maybe I would put here is introduce more micro grant type of innovation sandboxes also at the institutions, at the universities. That are working jointly with what is being offered internationally, among the European grants and projects. And then do hybrid models of public-private partnership, because it's no longer possible to do this on its own, and find a connection. And I think actually EIC is doing some of it with the EIC fund. That is being set up and encouraging some of these new ways of doing things. And then redefine success in a different way. So measure not only the outcomes, and especially with disruptive innovation and with scientific, let's say, breaking barriers type of work, you have to support a longer process that is not only project-based, but one that is rewarding also the progress on how you get to that, because life cycles are much longer than we are used to, and we need to look at a way on how we support that whole process of getting to that final outcome that we want to achieve with innovation.
Thank you. I'm amazed at the diversity of topics that we've already touched upon. And I'd like to bring us into the Institutes for Higher Education. And this is a question I'm going to be directing to Orla and Heinrich, please. How can universities fundamentally change their internal structures from things like promotion tracks being based on historically academic criteria to resource allocation? How can we better incentivize and protect researchers who want to pursue wild ideas that do carry this very high risk of failure? What mechanisms can be put in place to ensure that researchers are rewarded for being ambitious in taking risk?
First of all, researchers need to be supported. There need to be certain fundamentals in place if this is to be a possibility for research. So we need to check that across our systems, that we have grants such as those of the ERC that support fundamental research. We need them in our national systems as well. We need an environment of academic freedom where researchers know that they are free to pursue areas of interest. We need, and again this point was made at an earlier session by Maria, we need researchers not to be so tied down with writing midterm reports and financial reports and final reports and et cetera, and writing, 20 grant applications for every one grant that they receive. There needs to be security of tenure for those who are involved in researching these areas so that they don't feel that precarity which limits what they can do. So those are some of the basic building blocks that you need. Then you need institutions to come in. You need institutions to support a porosity between the universities and the commercial world in all the many ways, starting at undergraduate level. We need to make sure that that porosity is there, the walls are pulled down, up through graduate school, and then on into researcher and faculty positions. We need strong technology transfer offices, and we do need these to be reflected in things like promotions criteria, and that can be done. It is done in very many universities. So I think universities are becoming more creative, more dynamic in how we address this, but we live in a broader ecosystem, and all of the ecosystem has to be pulling together if this is really to work.
Yeah, very well said. Anything you would like to add, please?
So part of the answer of your question, Stacey, lays in your question already about the institution, and Orla mentioned that as well. So universities are institutionalized vehicles, more rigid than other organizations, as a matter of fact. So they have severe difficulties in allocating funds, especially when it comes to pre-funding something. And that's a tremendous obstacle. Now, there are three ways to overcome this obstacle. Number one is higher base funding, and I'm totally for this. Less program-based, more base funding anytime. Number two is to create institutions that are flexible enough to actually deal with ideas that we might have for incentivization, etc., and so on. And one vehicle which seems to work well are public-private partnerships, where third-party institutions come into play. But they need to have a long enough tenure, so you cannot work with tranches of 18 months, 3 years, and so on very well. So we need to go into 10 years tranches. Even that is difficult for universities. And then number three is of course third-party funding, and there come the established companies and everyone else to give in money. European institutions discover now foundations where rich individuals, and we have those in Europe as well, can make their contributions. That's very non-established so far. That's chance number four. But we need to help the universities to create additional institutionalized structures to actually work properly with this.
Thank you so much. And let's say in a magical universe, we've cured all of these issues. They're all fixed. I'm going to direct the next question to Raphael and to Mark. For the researcher and innovator who's coming out of one of these universities now, this magical, all-fixed university, to take their idea from the lab or from the discovery phase into something that's more applied, that has more societal impact, or that can be commercialized, what is often the greatest structural or cultural walls that they then hit? And are there ways to better equip our innovators and researchers to be able to incubate these sorts of ideas and get them out of the university and into society?
Well, first, I would say they should do this now and not wait for the perfect university, because this may take too long, right? We need you now. You need to regard this as a career path. The systems are very closed at the moment, and when you get to university, you come from school, you know nothing about entrepreneurship and this opportunity that lies ahead of you, and you're not being taught that in any way. So the first hurdle when you come out, and I'm finally answering your question, is that you have to learn entrepreneurship, because now you're an entrepreneur, right? And they didn't teach you much of that. So maybe number one, find you a good partner that knows stuff about this world outside of your old system. It's quite a system too. It's no magic. Usually scientists tend to be very intelligent and learn quickly, so it's easy to learn, but you know nothing about it, most likely. It's very rarely you do. This is why at SPRIND we have programs, we call it Talentwerk. We have these wonderful German names, compound nouns, that's fun, where we teach you these things, because we know we have a co-founder program, with people that built and sold a company and know the commercial part very well, that we put you in touch with so that you can build your teams. The thing, I guess, that may be most limiting when there is a perfect university, I could go back and talk about transfer offices and other things that don't really work that well, IP transfer and things. We're working on that as well. Is that your surroundings, your friends, the culture that you're in may not encourage you. They might say you have a pretty safe job, see that you become a prof and get a lifelong tenure, and then you're done, and then you get a pension, and then you're going to die happily, right? Or there's excitement out there, and you do crazy shit, and you might get rich, but this is not what drives most of the people. You can do real big stuff driven by yourself, much more self-controlled, but you have to explain this to your friends, because they will tell you that you're nuts.
And your spouse.
That's the most difficult part.
Your partner. Please,
Yeah,
Mark.
I've got a couple of points I'd like to make. I mean, firstly, I think the culture is changing amongst generation, whatever the generation is now. I lose track. But there is that culture that the young people don't just want to be researchers anymore.
Yes.
They see entrepreneurship as part of what they would like to actually move into. So I think we do have a big opportunity there. The challenge is, of course, then harnessing that desire to actually innovate. I tend to agree traditional KT functions in universities are quite conservative, quite small, do what they can, but there's not necessarily the right culture. What I've seen work well, certainly in my previous position, where we ran major national laboratories, we had a big focus on business incubation and really set up incubators at different scales. Lowest scale was an office somewhere where we would basically charge almost no money, but with business support around them, up to big labs, and you can actually then help these young, innovative people grow their businesses, but proactively giving them the right business support or the entrepreneurship support. Then you can get them to scale up. You can actually, and we did very successfully scale up a number of businesses. And then in the UK, like in Europe, no venture capital, so it's scale up, sell off. And that's a problem. And Europe has to solve that last bit of the problem, I think. So that business incubation, active business incubation, I think is very, very powerful, very important. And in my previous life, typically we were incubating 300 companies at a time, something like that, which is good. But on a national scale, it's a drop in the water. And that's a bit I would push on. In terms of high risk, there's another thing I think we really sometimes miss, and I gave a lecture actually at the London School of Economics, which was terrifying. So I talked about the Higgs boson a lot to scare them, and then they scared me. But actually, sometimes some of what we do in big science is our mission is purely scientific. We don't go to innovate. We don't go out to innovate. We just try and answer the impossible question. And we say, we need this technology. It doesn't exist. So we actually go out and make it. So things like, so this old hat, the World Wide Web, came out of CERN. Cloud computing actually came out of CERN. Synchrotrons, structural biology, came out of developing accelerators. So these big mission-driven science ideas give you real disruptive innovation. But then how do you harness that? And that's the bit I don't think we do so well in Europe. But being positive, I think we have a massive opportunity, actually, because firstly, we've got loads of smart people in Europe. There's no question. Smart young people in Europe, no question, with an appetite to innovate. And we have the EU and all of the EU instruments that actually can act at scale across Europe, much more effectively than we can do nationally. So in the draft multi-annual budget, there are now these moonshots, which are really high risk. One of them is about particle physics, which is why I like it. But a lot of them are around real high risk disruptive technologies where, if this goes ahead, it's a draft budget. These are disruptive technologies with very significant investments at the scale where Europe can then compete, hopefully, with the US and other competitors.
Thank you. So I'm going to direct this next question to Milena, and then we're going to open the floor for some questions from the audience. But you have such an interesting background and have touched so many of these issues that have already been mentioned at the table. So if we all accept the fact that these wild ideas or these moonshots are essential to long-term strategic competitiveness in Europe, which it sounds like we all do, what are the most important changes among academics and policymakers and the public that are the most crucial in your mind for fostering this kind of ecosystem that we're all talking about, where intellectual curiosity is prioritized, where failure in the pursuit of breakthroughs is something that's just part of the fabric of the culture, it's widely understood, and it's embraced as being essential to learning?
Well, thank you. This is to me, a critical question, and it's about that paradigm shift that we've been talking about in Europe. I would start with what Mark built on what Mark was saying in terms of education and how to respond to what the younger generation and our future creators actually want. They do want more entrepreneurial way of learning. They do want more opportunities where they could be experimenting, testing, and maybe not necessarily be evaluated on the capacity of how much knowledge they gathered or developed, but more on the way they are acting on that knowledge, on their performance of how they interpret and digest. And I think the age of people who want to be entrepreneurs is lowered. There are more and more digital and tech entrepreneurs that are starting younger because to them these technologies are closer. And I think we need to find a way to translate culturally that this becomes also the same way with deep science and with encourage that curiosity and allow for this kind of play at schools even, so that they move on and then connect it to universities, that they experiment. So another shift in the culture is to move from the risk avoidance, which is what we've been good at because we've been secure in the industrial and intellectual, let's say, scientific capacity in Europe. But now this needs to be matched and funding needs to catch up, to be faster. And similarly, like funding for knowledge needs to be VC-like. This is what you also mentioned. If we are to meet that expectation of a culture change. And I think one more point I want to make with regards to researchers. Researchers need to start to be rewarded for iteration and for experimentation, and not so much for the final outcome that is being given. And maybe the last point is that we need to start making cool and sexy the fact that we're innovating and that we're trying and that we're experimenting. And we need to have more stories, also of scientists turned entrepreneurs who are making it big time. So rather than, sometimes we kind of tend to focus on what is not working. We need to start being more optimistic in saying what's working out of these good examples, because people want to associate with success and want to associate it with and they need more of these role models being promoted. That's why I think being here and seeing that this is happening here is, to me, has been very encouraging for Europe and maybe being optimistic. So let's just be bolder about what we see as a way of doing things in Europe, and counting on the fact that we have we have researchers, we have capacity, we have potential, but we need to support that potential to get to the market.
Thank you so much. So I'm happy to open the floor to the audience. We have about 12, 13 minutes to take questions. Yes, behind me. And please introduce yourself.
Hi, I'm Diane. I work at a Marine Research Institute in Madeira. I heard a couple times throughout this panel things about we need to have the best machines, the most funding, a lot more investment needs to be made. Are bold ideas, are the most wild ideas, always the most expensive ideas?
Mark says yes.
Yes and no.
That's a great question.
So a follow-up would be, is there a bias that this is the case, and could that be holding us back?
Can I start with that one?
Yes, everybody can.
Yeah, I don't think that's right. I don't think it's the really big things that are necessarily the most innovative ideas. But at some point, if you're going to take your brilliant idea developed at a small scale to something really large, you hit that point where you have to scale up. And then, so it's really a question of scaling, not where you start from. And that's the bit, I think, where we have a structural weakness in Europe.
So, two observations. Number one, there is a very well-known consultancy that ran around in the early 21st century and said innovation outcome is not related to funding. And then there was, during my role as a responsible person for R&D at Telecom, always a thing, Heinrich, why does it need to be so expensive? And so I did the analysis. Here we go. And here's the answer. I analyzed...
Did he plant you?
I analyzed the 450 unicorns in the Crunchbase Unicorn Leaderboard and made the ratio to the investments that's being made. So the average cost of 1 billion value of a unicorn is 240 million euro investment. And the cheapest unicorn was 100 million. So there is no global business impact that comes for cheap. Yeah, I can send you the numbers again later.
But really, let me add one thing. This is sort of the final outcome. Of course, you need a lot of money for scaling, like we said. Maybe in research, that's not always the case. You don't always need a big accelerator that costs gazillions. And we see the difference at SPRIND. Some people are really happy when they get 100K or 200K because it gets them a long way as long as this money is flexible and they can do with it what they want. It drives them forward quite a bit. This is why when I talked about the challenges, when we get project applications, the first thing we're trying to get out for the things that we like is what we call a validation contract. It goes to 200K, and it makes a hell of a difference because we can get this money very quickly to the teams. It's almost a paid due diligence for us because we see how they perform. And then we can add other tools of funding and eventually phase over to private funding where we can co-invest. So we can do the whole enchilada, so to speak, from sort of state funding, but fast. Time to money at challenges is 14 days from application to money in the bank account. For projects, it's more 2 or 3 months because it's very individualized. And it's not a lot of money in the beginning. But if stuff then starts working, this is where you get then eventually. But this is scale-up money, much more low-risk investments, much easier to get. But I mean, you can do science at home that is impactful, right, for no money. And we don't hear much about it because it's not running around on the outside screaming for money. They just do their thing, right? Back in the day in electronics, we could do that, right?
And if I can just add to that, if you look at the wild ideas that are really changing the world, they take a long, long time. It's wonderful to think of some great explosion in a laboratory that immediately delivers the impact, a good explosion that is. But, you know, you look at artificial intelligence, the LLMs, look at how many decades they were in gestation before they really emerged. Look at mRNA vaccines, look at weight loss drugs, look at how long it takes, not just in the scale-up and the innovation, but even in the research to solve challenge after challenge to get something really, really meaningful emerge. So I don't think that we can be too naive about thinking about wild ideas emerging and immediately landing in innovation outcomes. Sometimes that can happen, but more often the ideas that change the world take a long, long time to come.
I just wanted to give a bit of a different perspective, and it is bold ideas are all of the ideas that are new, that are creative, okay? And to me, it's about investing also in the ecosystem and in building a critical mass to support many bold ideas. And then you would have a bold idea that will make it more than the other ones. But without this different approach, systemic and nurturing of people having bold ideas, to think out of the box and to believe that they could be the creators, you don't come up to the boldest idea that you know beats all the others, you know, makes the breakthrough.
Thank you. Any other questions from the audience? I see a lot of hands, but I saw yours first in the back by the railing. Yes, you. Back, sorry. I'm pointing like all the way in the back, all the way in the back.
Okay, thanks. My name's Eric Woods. I'm a postdoc at one of the Max Planck Institutes. Do you think that the difference in intellectual property rules between some European countries, like in Sweden, where you invent it, you own it, or in the case of Germany, where it's really hard to back license it from universities, makes a big difference? And are there efforts underway to try to make this easier?
Let's try to have one answer from the table, if that's okay, so that we can get to the folks who had raised their hands.
For Germany, we have a program called IP Transfer 3.0. You've heard of that? I mean, you're exactly right. It makes a huge difference. Yeah. I guess we all agree on that. And the easier, the better. You know, in the coalition agreement, we say it can only take 24 hours to get to your IP. I'm going to live to see that, maybe. But if it would be 3 weeks, it would be great. Right? But the conditions attached to getting the IP are even worse. So we try to standardize this. There's always an excuse that subsidy law is in the way and what have you. There is short-term greed instead of long-term greed. We should just let them go, do 100 of them, and one of them will fly, and then you get your money, and not financed by drawing cash from the startups. So yeah. But it's in the works, and I can assure you that the Minister of Science here in Germany has that high on the list, and we're executing it. This is why I know.
Thank you. And the gentleman who I didn't permit to ask his question.
Hello, my name is Horst Stamler. In my first life, I was cluster manager in Munich and helped more than 100 companies to get, or teams to get started. Now I'm with a foundation and just provide some 10 postdoc fellowships to interesting proposals. The good part is there I can make the decisions, in contrast to organizations who rely on a jury, on evaluators. And I think you forgot a very important group here. Evaluators, especially if they are working, let's say, from the back, they do not take risks. Yeah, that's the major problem. Many I've seen many proposals which I defended, but it's too risky. You can do that. I said you have to do that because this has the highest risk. Is that taken into account anywhere?
Actually, this is one of the points I forgot to make, because I think this is a huge challenge for us. We want to reward innovation. At the same time, we are putting people who don't understand innovation at the let's say the point where they're making decisions on how potential this innovation will be. So it's about changing part in the system, in the structure, that would allow that this becomes, that this has a clear pathway. This, in addition to the fact, excuse me, I just feels strange to be talking with my back to you. And in addition to transferring also the model from project-based per se to actually something that makes sense in terms delivering a more integrated result that could lead also to product or service or to innovation on the market that will support society, is another thing to reconsider in terms of how these also calls. That's why I was suggesting that we need to think of those calls and project funding as fail forward, as a way, in a way, looking back from the future on what this is supposed to produce in order to have the impact for innovation.
Thank you. So that's a very good point.
Can I just add something?
Yes.
I mean, I think it's a really good point, and it comes down to if you're investing in a capital portfolio, you don't just invest in low-risk investments. You will have a portfolio of risk. We do not do that in innovation. The tendency is to invest in low risk. Something will come out, but not very much. I don't know how you do this. I don't know how you implement a risk portfolio approach in peer review. Now, if you could do that, you could then perhaps start to address the issue you're talking about, but it is definitely an issue.
Actually, in challenges is exactly what we do. And we have an external jury, which is diverse also from a standpoint on how they're looking at these things. So there's investors, scientists, all kinds. And it's a group of maybe 6 or 7 max. They invite the teams they want to see. It's maybe 20. And they choose 10 or 15 of those. That's the portfolio. And then when they come back showing the results, it's reduced to a little smaller group. At the end, it might be 4 groups, but you're learning on the way. And this enables you to take much higher risks.
So I'm going to come back to the table so that we can stay on time. We have a closing question for all of the panelists. I would ask you to be brief. In 1 sentence or less, what is the next step we have to take to break down the wall between wild ideas and investment?
She starts.
1 sentence or less.
Well, we need to fund, to meet curiosity, the way we fund certainty. So change the narrative and move to more trust, collaboration, and in a way optimism to start funding experimentation and curiosity.
Mark?
Take risks, do it at the European scale. I think that's the way we can succeed. It's very hard. I'm from the UK.
Come back.
But Europe, yeah, I'd love to. But Europe has a big advantage here, and acting as a big single economy is a huge advantage, huge competitive advantage, with huge potential. So take risk, but do it at scale.
So in a sense, time for grassroots is up. I feel that we need to put more pressure on the cooker. And Europe needs to act more strategic and selfish and direct its resources to strategic points in a more managed form. We have the data, what works, and we need to execute on them.
I think we need to actively manage as a priority the interface between great research and great innovation. I think we need to reduce the European tendency to regulate first and then think about innovation. We need to turn that on its head.
Amazing.
That's all the things that I wanted to say, but I guess the one that comes to my mind starts with yourselves. I think we need to act to change things, right? Well, we don't have a problem agreeing, on the diagnosis, but how do we come into action? And of course, starting with yourself is always the easiest because you have to wait for nobody. So break down this wall inside your heads, get out of your silos. Imagine a bright future that, gets you to where you really want to be, and just don't take all those constraints all too seriously. You got a life to live. Life is a dance and not a marathon, right? Because it has a pretty bad outcome. For all of us, that's at least fair, right? But on your way, you might just take more risk and have some fun, because it's
Enjoy
really
the experience.
enjoy the experience. Fail forward. I like that term.
Yeah.
You know, I only learned when I fell flat on my nose, but eventually you'll do it right. And this moment is the best experience that you can have, and it might make you rich, which is also fun. Right?
Amazing, amazing. So I guess the take-home message from today's discussion is, no matter what generation you are, Boomer, Gen X, Gen Y, Gen Z, Gen Alpha, it seems like nobody really knows who's who. Help make innovation cool and sexy, and go do crazy stuff. Please join me in thanking our incredible, incredible table of experts today.